Let's start with the standard manual explosion of an assembly to prepare it for, let's say, what we now call our new technical documentation authoring functions. So we have been working on our BOM. So with a BOM, you can automatically now create IDs, and the IDs you can automatically arrange in the layout so that they will be assigned and layouted according to your desires. You can do that in the automatic way. Of course, you can do that also manually. And there's also situations where you would like to have a couple of parts, the same parts having the same ID, so that's also possible to assign and to position. Also in such a situation, if you decide to do that afterwards, you can still edit them and then finally say, okay, I would like to have all these parts belong to the same ID. Another very important function for casting industry, molding die industry injection is a splitting function. So the goal is to extract the face of the upper and the lower face of a mold, of a die. In that case, what we have here, we also had to split one face. So we can really split the faces, we can extract the faces, we can define new splitting directions, and we also can manually assign certain patches to already existing patches in, for if you decide that this is correct to do. If parts are more complex, here's a nice example where in CAD we already got the splitting direction indicated by these wire objects, and now we select them one by one, and just to verify if, let's say, we really got all splitting directions complete. So at the end of the day, there must not be any remaining patch anymore. So we still have 17 patches. So once we do the last one here, you can see we end up with 0. One of the new analysis functions is for people who are really interested in some details of certain features. So this drill hole recognition belongs to our feature recognition option in 3DViewStation, and it gives you, it tries to automatically recognize all possible drill holes right now in your assembly, and tries to recognize the characteristics. So how deep is it? Is there a certain angle? So are there two different, or maybe 3 or 4 diameters of that drilling? We do have a wall thickness analysis function since a while, and we added last year the rolling ball method. Rolling ball wall thickness analysis is that fast in the meantime that we now also introduced a wall thickness measurement function. So you do not have to do the complete analysis for the whole part. You do it just at the point like all the other measurement functions. If you zoom in, you see the sphere indicating and showing where the diameter is. Instances is we have added a new selection method, like selection by color. We do selection by instance. So you select one part and it will select you all instances of the same part. Instances is a very important topic. So here in this example, you see that the left side doors are different instances, that, like the white ones, or all these cooler elements here are separate parts in the assembly. Now we would like to optimize that. So for doing that, we have in the geometry tools pane an option to manually optimize the instances. You could have also a setting to do that during import, to be clear. So you don't have to do that manually. And now we recalculate the instances, and if we select, go back to the selector by instance, you see that now immediately we will get all the instances selected. Why do we do that? One reason is that we would like to reduce the file size. So if we save out our result, what we've produced here, and compare against the original file, then you see that we already gained 30–40% of file size. But at the other side, it's also faster in loading, because renderer has only considered less unique parts to render. Another method in that area is the removing of normals. Normals are required sometimes for I don't know, sectioning and whatever, but we do not necessarily need to have them in the file. We can also generate them in runtime. And if we remove all the normals and then save out the file once more and then compare, you see again the file size has dramatically been reduced compared to the original one, and also the load time at the same time has been cut down. Another new thing we added is a turntable rotation mode. So typically you can rotate the geometry in all degrees, and now it's locked to the table. Especially for users who are not that experienced with all the various options. We know we have so many options for loading files. We introduced a new file import dialog. And this file import dialog should give you the most important parameters at the fingertips, saying, okay, would I like to have as fast as possible load, only geometry, or would I like to have all information that's possible in the geometries, or anything in between. So you have the choice. If you just want to have a look on the geometry, go on fast. If you think you have to do deep analysis, go on full, or anything in between. The mouse over indicates some options. File format support. So we have added as one example Revit. So we introduced that for the BIM space, AEC space. So you see here a new building, a new office building of us with a couple of floors, with the parking facilities and so forth. And as with every other file format, you can do sectioning, measurements, whatever you like. It's just a new file format, a vector-based file format, very popular in the space. Here's another example with them text annotations, a choice of stairs. GLTF is also a file format being used in the BIM space. We've also seen a name like GLB. It sometimes comes without edges. So in that case, we use our edge generation capabilities to generate the edges which we need for measurements, for instance. A last one, also file format, is laser scan data. So in this case, it's E57 point cloud file format. You see, especially in that case, being used to scan buildings or whatever. Okay, that's for now. Have fun with working with